All right, this is 13.6, rotations and symmetry, and we have vocab just like we've had this whole time here, so let's make sure that you're good on these vocab terms. All right, so make sure you're noting that this is a rotation, not a reflection like last time. So a rotation is a transformation in which a figure is turned about a fixed point, so you're turning it. So rotation would be turn, would be another good way to describe it. Remember, pause the video when you need to get the terms down on your paper. I'm going to try to zoom in a little bit here for you as well. The center of rotation is that fixed point about which the figure is rotated. So when we're rotating it about a certain point, its name is the center of rotation. The angle of rotation is formed by rays drawn from the center of a rotation through corresponding points on an original figure and its image. Okay, so a way to kind of summarize that big long definition is how many degrees you rotate it. Okay, how many degrees am I going to rotate that? Am I going to do a 90-degree turn, a 180-degree turn? Think about what a 180 turn would look like. If you were standing up and you were facing the front of the classroom, and I said turn 180 degrees, you would then be facing where? The back of the classroom. And rotational symmetry. What that means is that we have a figure, and it's going to have rotational symmetry if a rotation of 180 or less, clockwise, or it could be counterclockwise, it can go in both directions, about its center produces an image that fits exactly on the original one. So what I can do is I can turn that figure somehow, and then take it and put it onto the original, and it's going to match it perfectly. And that's when something has rotational symmetry. All right, so we're going to look at this next part here, and we're going to identify whether or not the transformation is a rotation. Okay? So here we are, we're on our coordinate plane, and the original is the dark one, and the image is the new one. And we want to know, did I rotate that? If I rotate it, will it look like this? Okay? So a couple ways you can do this, first of all. You could actually rotate your paper. So if I turn my paper, will it look like this one? Okay, so pretend that's quadrant 2 now. So it's pointing to the right on quadrant 2. Is that what it was doing? Oh, sorry, quadrant 4. Is that what it was doing in quadrant 4 that whole time? Here's my quadrants. 1, 2, 3, 4. Yes, that's exactly what it was doing. Now I need to describe it. So yes, it has rotational symmetry. And it is a 90-degree, not rotational symmetry. Yes, it was a rotation, and it's 90 degrees. Which way did we go? On a clock. Which way is this on a clock? Clockwise. So we would say it's a 90-degree clockwise rotation. Okay, now look at this one. I'm going to turn it one way or the other. It has to be 180 or less, so this would be 90 clockwise. This would be 90 counterclockwise. To go all the way over to here, that's a 180-degree turn. And is the small part going to be on bottom when I turn this guy all the way? So here's 90, here's 180. That would be quadrant 3 down there, and that's what that original guy looked like when I turned him down to there. Same with here, it goes up onto the image. No matter which way I turn it, we end up in quadrant 1, either direction. Okay, so you could say it's a 180-degree turn, clockwise or counterclockwise. So we're going to say it's a 180-degree rotation in either direction. Okay, now the next one, take a look. If I turn this guy and he needs to end up over here, that's 180, so I go 90, 180. Where's the point facing? It's facing to the left. But look at the image. Is the point facing to the left? No, it's not. Okay, so that is not a rotation. So that's what we're literally going to say. It's not a rotation, okay? Now, take a look at it, though. It's not a rotation, but what was it? You know what that is. What did we do? We went from here to here. It slid over. What word is a slide? It's a translation. That is a translation. Plus here, There we go. To help us here, we're going to talk about 90 degrees clockwise and counterclockwise rotations. So here's a 90-degree clockwise rotation. So let's take a close look at what happens specifically at the ordered pairs. A is x comma y, 2 comma 3, and now it's 3, negative 2. Okay, it was 2 to 3, and now it's 3 to negative 2. B was 3, 1, and now it's 1, negative 3. So can you see what's happening? The x coordinate becomes the y coordinate. So down here, if we're making notes of what's happening, when I change to my image, whatever the y value was becomes the x. Okay? But the x doesn't just become the y. What happened to its sign? Look at x went from 2 to negative 2. X went from 3 to negative 3. So the x gets multiplied by a negative. So if it was originally a negative, it would become a positive as well. So that's what happens in a clockwise rotation. Now let's look at counterclockwise. Here's my A, right back to that 2, 3. And where does 2, 3 go? It goes to negative 3, 2. Take a look at your B. B was 3, 1. And now it's negative 1, 3. So when it's counterclockwise, the y changes places with the x, but it ends up changing its sign. So that's where the negative comes in there. And the x was a 2, and now it's a 2 again. The x just changes to the y position, but it doesn't change its sign. Okay? So you're going to use these up here to solve the problems down below. You're going to look at that notation, be specific about what they say to do, and then you're going to flip the integers, the coordinates around there. So in example 2, we have a triangle ABC with these vertices. Then we're going to do an image after a 90-degree clockwise rotation. So we're going to use those notes up above there to do that. But the first thing we're going to do right now is we'll just make triangle ABC. So go ahead and do triangle ABC right now on your graph. Okay, and you're going to use a ruler or a really steady hand to make some straight lines there. So there's triangle ABC. Now I need to turn it so it ends up here clockwise, right? So it's going to be down there in quadrant 4 when you turn it. But I need to write out the coordinates to help me to do that. So 90 degrees clockwise was this one right here, so they become y, negative x. So what I usually do is I go through and all of my y values, I write them right away. And you know what? I want to do a different color so it's not confusing. So here's going to be my image. All the y values get written. So 1, 4, and 0. They just become the x's. But what happened to the x values? They don't just become y. They change their sign. So negative 1, negative 3, and negative 4. All right, so now we're going to draw that one. So this is 1, negative 1. Make sure you're labeling it A prime. 4, negative 3 is B prime. And 0, negative 4 is C prime. And then you can check it, okay? If I turn this guy 90 degrees, it's going to have the A on top. The C is going to be touching the y-axis, and the B will be way out there. And that's what happens when I drew it. Okay, so it's your turn. Go ahead right now, pause the video, do number 1 checkpoint here. You need to do the new coordinates off to the side, just like we did on this page. You're going to actually write this down right there off to the side, and then you'll have both of them graphed. So pause the video and go ahead and do that. Okay, so you should have paused the video. It should be done on your paper. And here's what I have now. The original is the red. It was down in quadrant 4. The image is in the blue, and it's up in quadrant 1. If you didn't get that, see Mrs. Wyman if you have any questions. Here's the notation you should have, though, just like we just had on the previous page. All right, well, what about a 180-degree rotation? Let's see what happens there. Now, first of all, it doesn't matter if you go clockwise or counterclockwise. It's going to end up being in the same place, so that's kind of cool. Clockwise or counterclockwise. Let's look closely at what happens to A and B. So A is at 1, 3, and it becomes negative 1, negative 3. Pretty easy, right? 2, 1 becomes negative 2, negative 1. So what happens? XY changes to negative X, negative Y. They just flip their sign, and then you go about your merry little way for graphing them out. So we will look at example 3. Okay, I feel like you can do example 3 on your own right now, so go ahead and pause the video right now, do the notation, have them both graphed out over there, and then unpause and come back and see how you did. Okay, so those should be done now. If they're not done, you need to pause the video. Otherwise, here's what you should have. Okay, the original is there, okay, and then the image is in blue, and I can see that I need my little prime symbols there to show that those are the image. Okay, see Mrs. Wyman if you have any questions about that. Otherwise, we're on to rotational symmetry. So rotational symmetry is when I can turn it 180 degrees or less and have it look like the same shape, exactly the same shape, like I never turned it at all. So this guy, can I turn him and have him ever look like this with the arrow pointing down? You can try it either direction. Okay, that way, no, that way. The only way I could turn him is 360, and that doesn't follow the directions because then we're right back to the original. So that guy does not have rotational symmetry. The figure doesn't have rotational symmetry. What about this guy? Now, when you're turning him, you need to pick all the ways that has rotational symmetry. So can I turn him 90 degrees clockwise? Yep, that looks like the exact same shape. It doesn't even look like I moved it. Can I turn him 90 degrees counterclockwise? What about, can I turn him 180 degrees, so it's totally upside down? It's still the same exact shape. So this has all of the above, okay? It has 90 degree clockwise and counterclockwise. Rotational symmetry, and 180 degree rotational symmetry. It has all of the above. Okay? Now, it could have less than 90. It doesn't just have to be 90 and 180. We've been focusing on 90, but it could be that same deal. So, take a look. If I turn this guy about, right there, that looks like the same shape as I had, the arrows pointing up. Or there. Or there. There is lots and lots and lots of rotational symmetry there. Now, if you're not sure how to describe it, I'm going to kind of make this look like a coordinate plane here to help you out. So this one would be 90 degrees clockwise to get to here, right? This one would be 180 degrees, either direction. So what's half of 90? How many degrees is that guy right there? That's 45 degrees. Okay, but right here, it's not 45 degrees, right? What's halfway between 180 and 90? Take halfway. It's 135. Okay, another way to find it would be add that extra 45 to the 90. That's 145. It has that kind of rotational symmetry, clockwise and counterclockwise. So the figure has 45 degree, 90 degree, and 135 degree clockwise and counterclockwise rotational symmetry. And it has 180 degree symmetry in either direction. Okay? All right, so that is the end of the online notes, and you're on to the next topic. See Mrs. Wyman if you have any questions about any of the items that we were talking about in the notes.